In this video, we will work on this problem from 2024, paper 1. First step, read the problem carefully, identify key points, what the problem is about. As you can see in this problem, we have a capacitor C0, resistance R0, inductor L, and a battery. So we have two switches, K1 and K2. Initially they are open, so initially there is no closed circuit. That means there is no current in the circuit, and the problem also says initially there is no charge on the capacitor. Now first we close the key 1, so that completes this circuit and the current will start flowing in the circuit. So the moment you close the circuit, the current is represented by I1, which will change over time, and it says that after a long time the current attains a steady state value I2. So we have to find what is I1 and what is I2, and then after that steady state we open switch K1 and at the same time simultaneously we close K2, and then we have this circuit complete, which is an LC circuit without a battery, right? LC circuit without a battery, and in that circuit the current will fluctuate, which we will see later. So when it fluctuates, the frequency of that fluctuation is omega naught and the voltage amplitude is V naught. So we have to find out I1, I2 in circuit RL circuit and frequency and amplitude for LC circuit, and only one option is correct. So let us start with the first part, this circuit here, right? So you can see it here. So we can write the Kirchhoff's second law. So the voltage drop from point 1 to 2 is minus 20, and then voltage drop from 2 to 3 is Ohm's law, IR naught, and then voltage drop from 3 to 1, right? We complete the loop according to Kirchhoff's second law is L di by dt, right? And we get this governing equation, and it tells you that the current will be an exponential function of time. Now here is something interesting. We do not need to solve this function, solve IT function, right? If you do that, you will spend more time. We can find out the current at time 0 and the current in steady state by logic, which we will see in the next slides. Let us look at the current at time 0. So before time 0, K1 is open, right? So the circuit is not complete, right? The circuit is not complete, so it is open circuit. So there cannot be a current. So I is 0. The moment we close the key, the current is represented by I1. And the question is, what is this I1? Now look at this term. It says this inductor here, right? It is opposing the change in current. So if you say, let's use the logic. If we say that this I1, for example, if this I1 is not equal to 0, so you are saying the current went from 0 to something instantaneously. That means di by dt is approaching to infinite, right? And we know that this cannot be infinite, right? It is not possible. Not possible, right? Because for that, the voltage required to change the current instantaneously in an inductor will be infinite, right? So this means that V3 minus V1 approaching to infinite. The voltage across the inductor is approaching to infinite, not possible. That means I1 must be 0. So we can just solve it by logic. Now, what about I2? So I2 is after a long time the current attains a steady state value I2. So after a long time, t approaching to infinite, I approaches to I2, which is steady state. And this is your hint. Steady state means the rate of change of current is approaching to 0. So if you put this 0, what would you get? You will get I equal to 20 by R naught, and R naught is 5 ohms. So that will give you 4 ampere. So we solve I2 4 ampere and I1 is 0. So if you go back to the problem, we solved this and this. I1 is 0 and I2 is 4. Now let us solve for the LC circuit, the second part of the problem. So in the second part, what we do, when the current in this circuit, RL circuit, has reached a steady state, we open K1, we break this loop and we close K2, so we complete this loop here, and that is an LC loop, LC circuit without a battery. It is LC circuit without a battery, right? So if you apply the Kirchhoff's second law again, just like we did for the first part, you will get voltage drop from 1 to 2, right? That is L di by dt, right? L di by dt from here, like this part, and then 2 to 1, which is across the capacitor. That is, so I will write, so this voltage here across the capacitor, V2 minus V1, right? So V2 minus V1, that is Q by C, right? Q is the charge on the capacitor, charge at any time on the capacitor, and Q can be written as integral I dt, right? Integration of current divided by C, and that's what you have. So you get this equation here. Now let us look at this equation. This is a simple harmonic motion, right? Second derivative of I and then I itself, so that is SHM, and the solution of that will be a harmonic function, right? So here's the thing, we do not need to solve for the this function. We can find the amplitude, the maximum voltage across the capacitor by using energy method in a short way, but I still would like to cover it because you will learn about some fundamentals, right? So let us solve this function. So IT is this function. We have to find what is A, what is omega, and what is phi. So let us start with this, that at time 0 we know the moment that K2 is closed, right, and simultaneously K1 is opened. So all the current, that 4 ampere that we had going through here, right, that will not go this way, instead it will start going this way, right? So that is the maximum current now, 4 ampere in this LC loop, right? So if you look at this harmonic function, the maximum value can be A, right? So A is I2. That's the one thing we learned. That means A is I2 for current, amplitude. Other thing, if we plug in this formula T equal to 0, we get A cosine phi. So from here we get A cosine phi, and by logic we know that at time 0 the current is maximum, right? So, and that maximum is the amplitude, which is I2. So A cosine phi equal to A, which implies phi is 0 degree. So that means phi is 0. So we get IT is basically I2, which is 4 ampere, and cosine omega t. That is the function we got. There is no phase. Now what is omega? What is omega? So you should know, for simple harmonic motion and LC circuit, it will be square root 1 by LC. You must know these formulas by heart when you go to the JEE exam. You will not have the time to find these formulas, right? So you plug the value of L and C, and be careful about, this is micro, sorry, this is not micro, this is milli, and this is micro. So if you miss that, you will get the wrong answer. See, micro and milli. Do not forget these small details. So if you do that, you will get 2000 radian per second omega, and that is 2 kilo radian per second. So if you go back here, so it says omega naught in kiloradians per second, right? So we get answer 2. We get 2. So we solve this 2, right? And what it means? It means that in this circuit, right, the current is fluctuating. The maximum current is 4 ampere and it changes, it fluctuates like this. So 4 ampere, then it becomes 0, then it starts flowing in the opposite direction, it goes like this, right? And the frequency is 2000 radian per second. And because current is fluctuating, so see here, so the current is accumulating the charge on the capacitor and moving and releasing the charge, right? So the current, what is current? That is the rate of flow of charge. So I is dq by dt. So the charge at any time, the qt, it can be found by integrating the current over time. And we know initially there is no charge on the capacitor. There is no charge on the capacitor. So q at the charge at time 0 is 0, right? So if we integrate that, we do the integration, you will get that the charge over time is I2 by omega sine omega t. So the charge on the capacitor plates is also fluctuating, right? It as a harmonic function. And now the voltage across the plates, this is the formula for the relation between the voltage across capacitor plates and the charge on the plates, right? Q equal to CV. So the voltage across the plates of the capacitor is Q by C naught, and we have Q here, I2 by omega sine omega t. So you divide it by C naught, we get this function here, and that is the voltage fluctuation across the plates of the capacitor, right? And that's what it says. Voltage across C naught oscillates with amplitude V naught and angular frequency omega naught. Omega is the same for the current fluctuation, for the charge fluctuation, and for the voltage fluctuation, and we found omega already, 2000 radians per second or 2 kiloradian per second. So now here I2 by omega C naught, and you plug the values. I2 is the maximum current, 4 ampere, omega is 2000 radian per second, C naught is 10 micro, so you will get 200 volt. So that is the fundamental way of thinking, like you can use the current to get the charge, to get the voltage. But in the JEE, the time is very important. So if you use the energy method, it can be faster. So in this circuit, there is no resistance, right? So there is no energy loss. So energy is conserved, right? There is no R, so no energy loss. No energy loss, right? In this circuit. So what is the total energy at any time? The energy is stored in the inductor, this one here, half Li square, and this energy is magnetic field energy, right? And then in the capacitor you will also have the energy. So in the between the plates you will have here, you will have electric field. So you have electric field, right? And the energy in between the capacitor plates is stored as half C naught V square. So at any time the total energy is constant. So I equal to 4 ampere. Is the maximum current. When the current is maximum, all the energy is stored as magnetic field energy in the inductor, and that is half Li square. That will give you, if you put L and I 4 ampere, you will get 0.2 joules. But at that time, the voltage across the capacitor plates is 0, the Q is 0, right? The voltage across the plates is 0. So the minimum, there is no energy in the capacitor plates. But the other case is when the current is 0, all the energy is taken from, there is no magnetic energy left in the inductor, and that is 0. And all the energy converts into the energy in the capacitor plates. So that half C naught V naught square has to be 0.2 joules from here. And if you use that, then you solve it, you will get V naught 200 volts. So the takeaway message is, if you have this problem, if you know to use the energy method, you can solve it much faster than integrating the charge to get integrating the current to get the charge and to get the voltage. And here you do not need to solve for the first part. You do not need to solve the I as a function of time. You can use the logic to find, because you need to know I1 which is at time 0, and you need to know I2 which is steady state, and steady state is the keyword here. So if you do that, you can find the solution much faster, and the correct answer is, so V naught is 200 volt, right? So S5. So this one is the correct answer. P, that is 4. So I1 is 0, so P is 1, and Q, value of I2 is 4, so which is 3, right? So this is correct, and value of omega naught is 2, so this is correct and this is correct. The first option is correct option.